Hi, 7th graders. Happy Tuesday. Today we are on page 8. All right, I've got my fancy pens right here. So we are looking at theoretical probability. This is also a review from when we were doing our coin flipping and bottle tossing. Bottle flipping too. Okay, well, all right. So the blank probability of an event is the ratio of the numbers of ways the event can occur to the total number of equally likely outcomes. The theoretical probability. So that's the number of ways an event can occur to the total number of equally likely outcomes. So the equally likely is the part that we need to pay attention to. So if we are looking over here, equally likely outcomes, right? Look, there are 4 chances. I have 1/4. It's equally likely for it to land on blue, as yellow, as red, as green, right? Now, not equally likely outcomes. That's where you get a lot of blue and then smaller parts. That's when you go and you're like, yeah, I want to win that $100, and it's like a really small spot on the spinning wheel, and you end up winning like a cush ball or something like that. I feel like that happens to me all the time, but it's because I didn't have that likely of an outcome. It wasn't like I was going to win $100 or a cush ball equally. The $100 was one of the smaller slivers, right? Okay. When the outcomes in the sample space of an experiment have the same chance of occurring, the outcomes are said to be equally likely. An experiment in which all outcomes are equally likely is said to be fair. You can usually assume that the experiments involving coins and number cubes are fair, right? Because there really is no other way of like rolling a certain number every single time. Like where over here, you're more likely to hit a blue than you are to hit the smaller other ones, right? So, finding theoretical probability. So if we are looking at theoretical probability, we're looking at dice. I've got my dice right here. Sorry, I got my dice and my coin. All right, so here's my dice, right? 1, 2, 3, 4, 5, 6. So an experiment consists of rolling a number cube. Find the theoretical probability of each outcome. The number of ways an event can occur divided by the number of equally likely outcomes. All right, so how many numbers are on a dice? How many numbers could it land on? 6. So it is out of 6 equally likely outcomes. It could land on 1, 2, 3, 4, 5, 6. So out of 6, and how many is it rolling a 3? Well, there's 1 chance of that, right? Because there's 1 3 on there. If there were a bunch of 3s, then it'd be different. Letter B, rolling a number greater than 3. So remember, my denominator is going to stay out of 6, okay? And then a chance of it rolling higher than 3. Greater than 3. Well, I've got 4, 5, and 6, right? So that's 3 out of 6. Can I leave it like that? Nope. Simplify. Now, if I divide it by 3, if I do it to the top, I do it to the bottom. 3 divided by 3 is 1. 6 divided by 3 is 2. Beautiful. Next one, rolling a multiple. Sorry, my computer keeps making all these noises. I'm going to try and mute it. Oh, gosh. Sorry, guys. Okay. I think it's muted now. All right, letter C, rolling a multiple of 3. Okay, well, I've got to think of my multiples of 3. 3, 6, 9. Remember, multiples mean multiply. So, what's the chance of rolling a multiple of 3? Out of 6, well, I could roll a 3 or a 6. That's 2 chances out of 6. So, if I simplify, I'm going to divide the top by 2. If I do it to the top, I do it to the bottom. 2 divided by 2 is 1. 6 divided by 2 is 3. Sayla, I know you were saying it with me. Who else was saying that with me? Letter D, rolling a factor of 18. Now remember, factors are the ingredients. Remember how I would draw the cookie dough? So, 2 times 9, 3, and 3, right? So, factors. 2, can 4 go into 18? No, 3 can. 6 8, no, 9. These are all my factors. So I could do a factor tree like that, and then I have 2 times 3 is 6, or I could say, right, 1 times 18, 2 times 9, 3 times 6, nothing in between. Okay? So rolling a factor of 8. Remember, my out of stays the same. It's out of 6. So which one of these are on the dice? Well, a 1, there's a 2, a 3 on a dice, and a 6. No 9, no 18. So 1, 2, 3, 4. I've got 4 out of 6 chances to roll a factor of 18. Can I leave it like that? No. 4 divided by 2 divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. I've got 2/3 of the chance, right? Okay, so the next one, reflect. Sally and Lorena were discussing how to write the probability of rolling a 3 on a numbered die. All right, so we still have this going. Oh my gosh, look at that. Did you see that? Okay. What's the probability of rolling a 3 on a numbered die? Sally writes it as 3 out of 6. Lorena writes it as 1 out of 6. Who's right and who's wrong? Well, let me tell you why. You don't have to write it out because we're working on this together. But Sally is wrong because she is saying that there are 3 chances that there are 3 3s on this dice. Sally is wrong. And Lorena, because also Lorena is talking about the number of ways the event can occur. How many times can you roll a 3? Or what's the chance that you roll a 3? 1 time. If there were a bunch of 3s, then Sally could be right. But Sally's wrong because there's only one side numbered 3. So Lorena is correct. Okay? Okay, what a name, Lorena. Okay, down at the bottom, find the theoretical probability of each outcome. Write your answer as a fraction, decimal, and percent. Okay, here's where we're getting all the fun colors. We're going to make this fun. Randomly choosing a B from the letters in algebra. Remember, I've got to get my bottom, my whole. How many is total? So 1, 2, 3, 4, 5, 6, 7. Out of 7 letters, right? Out of 7 letters. The chance of me pulling a B out of algebra is 1 out of 7, right? So now here I go. I pull out my cell phone or your calculator preferred, but whatever. Actually, I don't even know if calculator is preferred anymore. 1 divided by 7 is equal to 0.142. Now, watch this. Remember, I'm going to write it down. I'm going to leave that there, and I'm going to write 0.1. Now, I'm going to round it to the 100th place. Usually, I'm going to leave this on my calculator, especially for what we were doing yesterday in math, but I'm going to round it to the 100th place. So, circle the digit, move to the right, and underline at 0 through 4, this number stays the same. So my answer is 0.14, okay? And then if I were to write that as a percent, it would be 14%. Sorry, I knew that one. I just wanted to make sure my legs weren't hitting the keys on my keyboard. Okay, so 14% because I would times it by 100. All right, so rolling a factor of 10 on a number cube P. Rolling a factor of 10 on a number cube. P. Oh, okay, well, let's go through our factors of 10, right? So a factor of 10, I don't know what the P is. That's the part I'm confused by. All right, so, I guess that's the probability. There we go, I get it now. The probability of pulling a B. The probability of pulling a factor of 10. Okay, well, if I'm thinking of factors of 10, it's 1 times 10. 2 times 5, 3, 4, 5, that's it. Okay, so now, out of 6 chances, right, because my number cube has only 6 on there, I've got a 1, a 2, and a 5. Oh, that's 3 out of 6, okay? So what would that be as a decimal? 3 divided by 6, some of you might already know this. 3 divided by 6 is half, so it's 0.5. Write that as a percent. Times by, remember I times it by 100. 1, 2, it'd be 50%. All right, I meant to switch my marker and I didn't. Next one, a spinner is numbered from 1 to 10. The number is less than 5. What's the probability of the number being less than 5? Well, how many options do I have? Out of 10, how many options do I have that it would be less than 5? 1, 2, 3, 4. 4 options. Now, what is the reason that I wouldn't put 5? It's because it says less than, not less than or equal to. So, can I leave it like this? No, I've got to simplify. Oh, I should have simplified this one too. That should be 1. Take a 3 out of the top. 3 divided by 3 is 1. Take a 3 out of the bottom. That should be 1/2. Okay, I'm going to take a 2 out of here. If I do it to the top, I do it to the bottom. 4 divided by 2 is 2. 10 divided by 2 is 5. 2 divided by 5. What does that get me? 0.4. Oh, I like it when I don't have to round. And then what is that as a percent? 40%. Remember? To the right. Every time I'm moving a decimal 2%, I'm going to times it by 100 and move the decimal to the right 2 times. Man, I need help. Emmanuel, help me. All right, rolling a 2 or greater on a number cube. All right, again, we're assuming that all of the number cubes are 1 through 6. So it's out of 6. All right, and rolling a 2 or greater. Ah, see, that's the difference. Where this one was rolling a number less than 5, this is, I'm counting 2. So rolling a 2, a 3, a 4, a 5, or a 6. Well, I've got 5 chances of that, right? And so if I have 5, 6, that is simplified, right? And then I'm going to do 5 divide, oh, don't do a user error like me, again. 5 divided by 6 is equal to 0.8. Now remember, circle the digit, move to the right, and underline at 0 through 4. This number stays the same, 0.83. What's my percentage? 83%. Okay, gotta get that marker off my phone. Okay, and last but not least, look at how short this video is today. Rolling a factor of 36 on a number cube. Okay, remember factors, 36. So 1 times 36, 2 times 18, 3 times 12, 4, 36 divided by 4, is that 9? Let's just check. 36 divided by 4, 9, yep. 4 and 9. Hey guys, it's not bad to use your calculators, right? It's not a bad thing. And then 5, no. 6 times 6 is 36. Okay, so here are all my factors of 36. Rolling a factor of 36 on a number cube. So what's my whole? How many numbers can I roll? 6, right? And so 1, 2, 3, 4, and 6, 9, 12, 18, and 36. Can't do it. The dice doesn't have that number on there. So 1, 2, 3, 4, 5. 5, 6. Oh, look at this. 5/6 of a chance. 0.83. 83%. Okay. Now, let me go back here to number 4 just real quick before I set you guys free. Number 4, the homework is giving me a different thing. They're saying 2/3, so they're saying 4/6. So let's see if I did something wrong here. All right, rolling a 2 or greater. So 2, 3, 4, 5, 6. Yeah, I think maybe they meant rolling greater than a 2. So I'm going to stick with this. But Miss Underhill, let's chat about number 4. In the Zoom meeting, and let's just talk about the wording, okay? Because I don't want the 7th graders to get confused. I guess similar to as how I would, but I just feel like I'm reading too far into it. 7th graders, the next thing I want you to do is please do page 9. All right, page 9 before you come to the Zoom. Keep doing what we've been doing. Make sure you pay attention to the whole. Make sure you pay attention to the bottom. All right, remember, text or send us a message if you need any help before then. We'd be happy to help you. Have a great day, 7th grade.